Welcome to the University of Pittsburgh's Health and Explainable AI podcast. I'm your host, Jordan Gospore, a health and science reporter. Join me as we cover advancements being made in health informatics and explainable AI for students, researchers, and healthcare practitioners interested in applications of artificial intelligence and machine learning. This podcast is produced by the University of Pittsburgh's Health and Explainable AI Research Laboratory at the University of Pittsburgh School of Health and Rehabilitation Sciences Department of Health Information Management. Headed by Ahmad Tafti, Pitt's HexAI Lab cultivates extramural collaborations with academic institutions both nationally and internationally through its research, educational contributions, and this podcast series.
Hello, and welcome back to Pitt HexAI, a podcast series produced by the University of Pittsburgh's Health and Explainable AI Research Laboratory. I'm Zoe Menezes, a student at the University of Pittsburgh, and today I'm going to guest host an interview with John Carbone, an adjunct professor of AI and data science in the graduate school at Baylor University. Brent Phillips, producer of Pitt HexAI podcast series, is joining us, and we're mainly going to speak with John about education in the AI age and how universities are adapting to the emergence of applications such as ChatGPT. Welcome, John. To get us started, would you like to introduce yourself and tell us a little bit about your background and your work at Baylor and some other work that you're involved in?
I stay pretty busy, and thanks for having me. I grew up in Germany. My dad was in the military. I went to Baylor University as my undergrad. Worked for Raytheon for about 30 years. Got to work on lots of really interesting projects and programs. And then now I work for a cybersecurity company for about the past 7 years. And then I'm an adjunct professor. I teach the applied AI and applied data science in the grad school at Baylor. And I'm on the board there as well at Baylor on the computer science and engineering board and support their curriculum development. I like to write lots of papers and books. It's kind of a fun hobby to do on the side, actually. I call it keeping my sanity from my day job because you get to think of lots of really great things to write about, etc. And I have a number of good friends of mine that also have the similar passion that we write a lot of books together.
Considering how ChatGPT has impacted education in such a short time, how do you think education is going to look in the future?
Yeah, so what I can tell you is that I think it's a very good and very timely question because every few years, Baylor pays me to redesign some of the coursework because especially in my field, right, they actually have to pick and choose where they put their money. So some fields, that may not change as often and maybe a little bit more static, not as quite as dynamic as AI is, changes pretty often. So now after 3 years of teaching it at Baylor, they pay me to redesign it. And so I think when you look at all of the tool sets and the generative AI components that are out there now, there are many of them that are built upon large language models and other things, you have a couple of choices. You can be fearful, which a lot of people are. And I think that's primarily because they don't understand and because of all the mis and disinformation out there, or you can completely embrace it. And I think when you go back to the Industrial Revolution, even though it's a little bit different than that today than it was back then, there are many, many similarities. Lots of fearful people thinking they're going to lose their jobs to the automation, et cetera. And I think you have a very similar thing going on today. But I think what people don't realize is all the phenomenal new jobs that are going to be created with this blossoming new environment. And so, yes, people are going to have to relearn. They're going to have to change. They're going to have, they're not going to be able to stay in comfortable the way they are. It's an uncomfortable thing to go through this type of process, and they're just going to have to find a way to deal with it. And everybody will deal with it slightly differently. I think some jobs will change and morph. Others will completely go away. And there'll be lots of brand new jobs out there. I'll give you an example of one that sounds kind of odd, but you might actually have humans that actually speak to robots so that they can actually teach them many kinds of things, the same way that they would teach a toddler in kindergarten or first grade or what have you. That may be an entire job. You may have, or you may have psychologists, right, that are actually do a lot of these interviewing. A piece of software that my cohort in crime, Dr. Jim Crowder, who's pretty well known in the industry as well. He and his daughter, who has her PhD, by the way, in artificial psychology, wrote some software to actually help psychologists learn the idiosyncrasies of each of the different types of, not diseases, but different types of psychological problems that people might have, like schizophrenia or et cetera. They have different characteristics. Like, for example, the software that they built actually interfaced to a visual interface that showed a human face that would show different characteristics that were scripted into the software. So, for example, if they're holding their head down and they're maybe not providing eye contact, all of those kinds of things are really important characteristics. So basically, they were using it as a tool to teach psychologists to learn some of those characteristics. So there's so many different jobs and so many different kinds of things that are going to come out of this. I think everyone's going to be really surprised. And then let me just add then, because I'm actually changing the class right now, I'm going to be teaching it in about 2 months, the next version of the class. I completely embraced all of the Gen AI things that are out there, and the entire projects that they will be building they will use any Gen AI tools they can find out in the wild, and they will be able to use them on the project. So in order to build those very interesting projects, to generate the code, to generate graphics, to generate their text. However, you have to balance those kinds of things with some robustness. And so what I'll be doing is I'll be asking them to give me lots of data around how well the tool worked for them, how much work they had to do to make modifications after the fact. Obviously, a lot of the Gen AI tools will not know a lot of the concepts that I teach. So I'll know if they misapply it to their project as well. And then the other thing I'm going to ask of them is also to tell me how well the tools functioned, et cetera. So there'll be a lot of feedback, because the entire objective shouldn't be to fear these tools. It should be to learn how to use them appropriately to solve a problem. It's like anything, right? You don't want to use a sledgehammer potentially to put in a nail, right? You want a regular hammer to do that. So you need to figure out what tools work, why they work, what doesn't work. And what's really interesting is that's actually part of the premise of the whole class anyway. And applying concepts, it's just another stage and another set of concepts to learn about Gen AI and how those kind of things apply as well.
It's interesting, later on in the interview, I was going to ask you for some words of advice for educators, but you just answered the question for educators and students. And it sounds like we're all in the same boat of learning this together. And I was going to ask you for some thoughts on how you would organize the class and what you would do. And this is really great that you're embracing large language models. And I was just looking at Perplexity AI, and it's a startup in San Francisco, and they're really good about, as soon as a new model gets launched, they're really good about adding it to their API, and people can start to experiment with it really fast. And do you think that, just diverging a little bit, do you think that education can keep pace with this explosive growth in generative AI? Like, should we be trying to keep pace, or, as you say, is this a new job description where the professor of the future will work in parallel with these advances and maybe not stress out about trying to keep pace?
So I think that the unfortunate thing about us professors is that we're not going to have jobs in the future. You will still need experts, right, to be able to help people understand topics and concerns and things like that. But so much material can be learned online that brick and mortar schools are going to have a real problem finding a way to stay alive, and also be able to make it affordable enough to have the college experience. Now, football and all those great things that are also tied into universities are still going to make people, at least for the near term, are going to still want to go and experience that, because there's a lot to that, and leaving home and all those things about, it's your time to go do your Christopher Columbus syndrome and go out and take over the world, or whatever you're going to do, and learn, find your way. That's still going to happen. Those needs are still going to be there, but there's so much learning that can happen in real time. Trying to keep up will be hard, but if we're going to add some robustness around the education so people can learn it in a way that makes sense, helps them make better sense of the material, I think that's still going to be necessary. So I don't know what it's going to hold, a decade from now, but I'd be willing to guess that it's only going to get more and more like that in terms of the characteristics that are going to be around then. Now, doesn't mean that you're not going to need higher education, because there's a lot of research and development that goes into things you can't just do in your garage. And a lot of companies, only have certain amount of money to do certain amount of R&D, and while they still try to sell things and create things. So it'll be a mix, but I think that you'll find that a lot of the education is going to come. A lot of people can do things on their own. But as well as I do, I mean, anybody that's gone to school, there are people there who want to be there and that want to learn. And there are others there that just want to get to the end. So those people are all going to have to find jobs as well. And so the material is out there. It can be done. You can get degrees without even leaving your house, so I hope that gives a little bit of the way I think things are going to be in the future. So
it's nice to think about universities. Some of them are so big that the turnaround time to just get involved in AI, it's so hard for them to rearrange education and pivot. And it sounds like you and Baylor are taking this seriously and moving really fast. Yeah. So
I think some schools are doing some fantastic things. I'll just tell you, I actually thought it was really neat. Just this week, while I was on my trip, I found that Baylor just bought an entire brand new environment, high-speed environment, so they could focus real heavy research into the AI space and quantum computing, which I think is where the real changes are going to be in the very near term in terms of what's going to be the most dramatic. It's not really going to be AI, but it's going to be AIs on top of quantum compute environments. That's where you're going to see a more dramatic change, because the speed of development, it's just going to be exponential compared to the last 20 years in terms of how fast things are going to change.
You mentioned technology in the future, and do you think in the future we're going to be wearing Apple Vision Pro headsets, and we have the new spatial computing environment? And
I wish I had the Google goggles from 10 years ago. I mean, absolutely 100%. I was actually really miffed when they went away, but they came out way too soon and they were too ahead of their time. But 100%, augmented reality is super useful, and it was useful a decade ago, and it's even going to be more useful, in the future. So 100%. Yeah, I'll be one of the first ones to buy them if I can get a hold of them. If they don't have to give up a firstborn or something to get one.
Unlock the future of AI at Pitt HexAI. Pitt HexAI is where the brightest minds at the University of Pittsburgh come together to push the boundaries of artificial intelligence. Tune into the Pitt HexAI podcast to hear experts discuss cutting-edge AI research and its real-world impact. Join us at Pitt HexAI and listen to the podcast today.
Exactly. That's funny. Hey, so it's been good to talk to you about just education and education in the future. And this is what we wanted to speak with you about last year. And it's just cool to hear your thoughts. And I think it gives students just ideas about, I think it gives us all ideas about how to improve AI education. And I thought maybe we'd switch back to health informatics and AI and hear about some of the papers that you've been involved in. And I'm looking at ResearchGate right now, and you've been involved in so many different projects. It's really cool. And you work a lot in psychology and methodologies for continuous lifelong machine learning and AI systems.
Well, so many of those papers, the common thread or theme through all of them is that you have to think about AI differently than just machine learning. And that's really where the majority of the mis and disinformation come from. So if you think about what it means to create diagnostics for anything that's not statistical, which is what all the parts of the large language model really are. It's all a probability bucket of data. And the problem is that has very little context. And so a lot of the problems that you're seeing in the market space where people don't do their due diligence after they use ChatGPT to help them solve a problem. Yeah, like the poor lawyer that's getting disbarred because he submitted his information to the judge and did not do the due diligence, and the large language models produced a bunch of fake cases that didn't even exist. So the point is, a lot of the type of machine learning and the neural nets that, whether it's in that paper or it's in the Color of Music paper, which is about helping people that are hard of hearing be able to appreciate music better, all of those things require a real science, right, on top of the use of these Gen AI tools, but you need context around the data in order to really make sense out of it. And so when the people developing the Gen AI tools finally realize that they need to capture the context around the information that they're collecting, you're going to see a vast change in their ability to be able to do things that they've never been able to do before. But they have to basically do a 180-degree turn from just doing pure probabilistics in order to be able to make really good things happen. And I think that's the common thread amongst most of those papers, is it's all about the context. The research that we've been doing for about the last 15 or 20 years actually is in the research of artificial cognition. And that's where a lot of this comes from, because the brain does not think probabilistically. It's not going to do the math and go, well, can I step up that next step? Am I going to calculate the probability of my shoes making it past the next step, or is there ice on the step? There's all context involved there, and it can't be probabilistically driven. So that's what I think is one of the common threads. One of the important things is that context has to be kept. And one of the examples I think I gave you last year when we started this discussion was, when you do a Google query today, when anyone does a Google query, you refine that query maybe 20 times until you find that piece of information you found. All of that knowledge you gained along the way while you were trying to find that exact thing that matched what you were looking for, it's gone. It went into the ether. No one kept it, right? Even Google doesn't keep it. What they kept was your initial query of the text that you put in and the results that came back. But sometimes finding the cure for cancer is maybe more important than the actual cure you found itself. The whole process of how you went about it. There's so many things that you learn along the way that are just lost. The context is completely lost. A topic, whether that topic was a topic from 2,000 years ago and the same topic today, that context really matters in the time frame that it happened or what have. But we don't capture that information. We don't save it. We don't store it. And once that's finally done, I think you're going to see a vast change in the way that science is able to create things, or machines that can actually learn, as opposed to machines that just remember, which is what machine learning is.
I remember our conversation from last year, and we asked you to offer a student a research project idea, and you emphasized that, like, it would be cool to build a system that can write all of its own code based on what it learns from data. And is this the future? Thinking about health informatics and medicine and healthcare and, these sort of complex needs out there and complex applications. And, I guess it's true that role of the future, one of them will be to help machines learn and help them generate data from data.
Yeah, so there's a number of concepts, right, in our book from 2014 on artificial cognition architectures that talk about those kinds of things. There's math involved, right, and certain constructs, right, that we don't put in systems today. Systems don't even remember what they do, so they have no way to learn from them. And so that's just some fundamental things that just don't exist. It used to be a big storage problem, but generally you don't really have that problem anymore. So some of those problems will slowly get away.
Just the notion of taking a data set, normally we just analyze that and produce an output to a question, but to take a data set and learn from it. Like, as you're saying, you have Google search queries and you just go from one query to the next. And what are we learning in the process? And to think about machine learning, training and fine tuning in that manner, it's really interesting.
So one of the formulas that we create in our solution is a formula on what we call knowledge density. So knowledge density is how much you know about a given topic and how something actually turns into a topic, right? Things of that nature. There are other formulas on analytical competency. So internally, humans think internally many times about how they do something, and can I do that better? Or what do I have to do to do what I'm not doing so well better tomorrow, right? That's an analytical competency that you do, but how do you do the math for that so that a machine can provide its own analytical competency on what it thinks it knows and what it doesn't know? Another really important thing is where something happens is really important. Have you ever seen in any large language model or anything where anybody even cares where something happens? And so there's lots of little idiosyncrasies like that that cause major challenges in these types of Gen AI environments. But in order to create machines that can actually learn, there are all these other constructs that you have to have in order to make them operate a little bit more like the way humans do. The point is, if we don't create machines that can actually learn from their environment that they're in and understand what their real objectives are and how to make those objectives a reality, it's very different than a probabilistic machine learning problem, where you're just collecting lots of data to sift through it. That's the thing. A lot of times that seems like it's always a dig on machine learning, but it is not, because there are very specific, fantastic uses for it and support elements that ChatGPT brings in, these environments where maybe it only has very specific contextual data about specific topics. It can provide superb value because it can sift through massive amounts of data and provide some value there. So there is perfect value in machine learning, but it is not the be all end all that's going to create the magic singularity and create fully self-evolving systems. There's a lot of other things that have to go into it, and I guess that's the point I'm just trying to make.
Just out of curiosity, a lot of universities, everything has to be accredited, and there's a whole sort of turnaround time to do anything. Like I know a University of Texas at Austin, they have a new AI program, and they seem to pulled it together super fast to meet this new need. And a lot of universities it's just hard to turn around and to, again, credit things and devise a whole program. But do you see this as a problem for universities?
Yeah, I think, some of the schools that have a lot more money, like a University of Texas that is really large and has a large following, and, they have the ability to generate some things a little bit quicker, put more resources against things. And some of the smaller schools will have a harder time. But I think if they're flexible enough, there's plenty of adjuncts out there that can support those type of environments that have, that can generate material. The other thing is, because so many people are focusing on machine learning only, or more on machine learning, it's a little bit easier for them to put these things together because, you're teaching algorithms, you're teaching ChatGPT, you might be teaching some additional, things around those subject matter. But if you're going to do a true AI course, in my opinion, it takes a much broader brush in order to do it correctly. And that's not being done. So I think, I haven't seen the curriculum. Maybe they're doing some really fantastic things, but I think that doing it correctly and doing a broad, all of the topics that really need to be discussed across AI, it requires a lot more than just the machine learning component, which many of them are focusing on. At least that's what it seemed like to me. I could be wrong about that.
Thank you. I guess I'm struggling with that. And in all the universities, they're trying to pivot as fast as they can as well. So I think everybody's in the same boat.
Yeah, I think they don't know what they don't know in a lot of cases too, which is you have a lot of professors that are really smart, but very few of them have a clue what large language models are. So they have to do their homework and they have to learn too to figure out how they could apply the content or what have you. I think what's critical is that we begin, and I think maybe AI is going to actually do it for us. It's going to be a forcing function. One of the biggest problems we have today is that education is not applied anymore. It's not applied education. It's regurgitation education. It's memorization, pats on the back for memorization, and that in terms of how well you remember, not necessarily that you understand how to apply the topics and the concepts. And applied AI, which is reason why I teach my class that way, is you have to physically learn how to, every one of those professors has to learn how to apply the Gen AI tools and things to their discipline. That's going to change the way that they teach it, I'm hoping, because it by default makes you learn in an applied way. So we'll see what happens with that. But
do you think universities of the future are going to need to be more like boot camps, like tech boot camps, and really think about education in reverse and think about practical skills and applied learning and stuff like that. So
Yeah, I think actually, I don't think it's only the universities. I think you got to start in kindergarten and you have to change the way teachers teach classes and the way they teach information. Memorization is obviously a function of, now, if you can't remember at least two or three things, you can't actually put them together. So memorization is a function of it, but we focus too heavily on it today. And simple changes in the way that someone tries to teach subject matter can make massive changes in a child's brain all through their entire life, whether that child is in elementary school or eventually turns into an adult and goes off to college and learns really high-end type things. For example, changing the way that simple questions, right? Like, how tall is Mount Everest? And someone normally gives you the answer, whatever, and you pat them on the back. But what they really should be saying, asking or questions around the lines of how tall is Mount Everest today? It's a very different question, because then it begs, well, do you mean from sea level? Do you mean, is it into winter time when there's extra ice and snow on top of it? It changes constantly. And you want children and adults to think more openly about the topic and not just say, well, it's, however many feet and boom, done. And the answer, because that's not you're not generating thinking people at that point. You're generating people that remember facts. And that's not what we want. And I think that you can do that all the way down to kindergarten, first grade, all the way up through college. And I think completely change the way that things are taught, like they were 100 years ago when we taught them, well, when you have a bushel of apples and you take them to the market and they're 10 cents a piece, how much are you gonna earn? That is an applied problem that also teaches you math. And I think those type of things have to come back. And hopefully AI is a forcing function to help us do that.
So I'm switching subjects a little bit. It's really rare on this show for us to have an expert in cybersecurity who has experience working in the defense industry and is really interested in misinformation and disinformation. And, thinking about the healthcare field and the future of the healthcare field in the AI age, can you share some things that you think healthcare professionals and even researchers should think about relative to security in the AI age?
That's a really broad question, but I'll tell you that. So one of the things that I work in is critical infrastructure. And it's one of the things we're looking to try to solve problems in. And there's three main points there that, whether it's an industrial control system, a medical system, etc., all of those things have the identical problems that every other computer system has. And the way that the industrial control system community handles those problems, they think of things in three specific ways. And they have an acronym that they use. It's called CIA, and it stands for confidentiality, integrity, and availability. These are the three most important constructs for any system. And if you think about how important some of those systems are, there might be chemicals, massive amounts of chemicals that if they react in the wrong way or are mixed at the wrong time, you have massive explosions and all kinds of problems and challenges that you can create if things are not done correctly. So in the medical community, those three little letters are really important, I think, for those type of environments as well. When you think about them individually, you begin to, when you break your system apart and look at all the different components and you think of them in those ways, it completely changes the way that you might build them, the kind of security you would build into them. And I think if you're, normalizing across every system out there, that's something really important, I think, that they can focus on that'll help them determine what the right things to do. Let me give you an example. So confidentiality, everybody thinks encryption is the thing that's most important about everything, and magically everything's gonna be better because hackers can't see what's going on. Well, it's just not true. Cryptography is a great, part of that solution to help allow things not to be seen, et cetera. It's hard for you to make out what's in there, but confidentiality doesn't solve an integrity problem. Integrity is between every API in the system, between every system-to-system communication, between every network that sometimes are air-gapped on purpose because somebody doesn't want certain data to get mixed with other data, for example. All of those systems have a very specific interface. And there are very specific messages that are allowed to travel from point A to point B, APIs that determine exactly what type of data is allowed to be shared. But very seldom does anyone actually look at that content to validate that that is valid data traveling between those systems. And one of the things when hackers or whoever it is that are trying to gain access to your system or make it so that you have denied services or whatever they're trying to accomplish, if you actually build systems that work to handle the confidentiality, to handle the integrity of the data, to validate that all of those things are actually allowed to go from point A to point B, you range check all the values, you make sure that someone's not trying to stuff in your ranges to a robot or something that are going to cause it to go haywire, et cetera. All of those types of integrity checks are also required. And then availability is the number one industrial control system letter. It's the one that they care about the most because everything has to be up 24/7, 365 or bad things happen. And so availability is really important too. So building in the right levels of redundancy where you have to build them into your system are really critical. And generally, the more critical a system is, the more critical those three letters are in that type of environment. So I know those are pretty big generalizations, but I think that there's some of the three most important things that you can work on no matter what system you're trying to solve problems for. And it'll help you define the risks and where you actually have to, put your majority of your money to solve the challenges that you could potentially have. Because there's usually never enough money to solve every single problem. So you always have to prioritize. That's the unfortunate aspect of all of this. But
Zoe, you had a question.
I do. I just wanted to ask, going back to the student perspective, do you have any suggestions of any skills or competencies that you think are essential for new health informatics students?
So what I would say is what I tell a lot of my AI students. And what's a real interesting thing is that people come from all walks of life into the AI space. They all need it and they all care about it. So one of the things that's most important is be flexible. Be able to learn many new things much faster than you normally used to do it in the past. Be willing to take in new information, be willing to change your mind often based on the new information you learn, and be able to be flexible enough to, like a computer scientist, which I am, and engineers are in general, right? We have to write code in many different disciplines. But there's no way we can learn everything in one discipline, but you have to learn enough in order to really provide value in that space. And what's going to happen in the future is what AI is going to do, same kind of problem sets are going to happen. And you're going to have to be able to switch gears faster, find ways to learn the core, what I call the first principles of a discipline quickly, to be able to understand it enough so that you can actually provide value in that space. And I think that's highly critical for any student in general, but I think it's even more so in the scientific side of things, because so many disciplines are converging right now, and it's only going to get faster and it's only going to converge more.
I was going to ask you to close the interview with some advice for students, and you just did.
Okay.
You're reading our minds. So thank you so much, John. It's been such a pleasure having you on the podcast series. Your work has always been so interesting. So,
well, I appreciate that. It's fun, and I spend most of my time, I think, dispelling rumors and misinformation in the AI world, and give some concrete tool sets to the students so they can actually walk away and really apply artificial intelligence the right way to their projects that they do out in the real world. Because I think that's one of the biggest problems that we have today is there's so much misinformation out there, and there's so much hype that a lot of times just the really important things get lost in that maze. So
That's great input. So, John, thanks again for letting us interview you and for sharing your views and insights on AI and education in the AI age.
Thanks everyone for tuning in and for following the show. The Health Unexplainable AI podcast is produced by the University of Pittsburgh's Health Unexplainable AI Research Laboratory at University of Pittsburgh School of Health and Rehabilitation Sciences Department of Health Information Management. I'm Jordan Gaspore. Thanks for listening.